Everyone, I'm Mr. Baker. We're going to continue in my environmental science class talking about our waterways and how the earth naturally handles pollutants in those waterways. We're also going to talk a little bit about the steps scientists are taking to remove pollutants from those waterways. So when we talk about waterways, we're not talking just about rivers and streams and ponds and lakes and creeks. We're also talking about aquifers and oceans. All right, so we've already talked a little bit about aquifers. We've already talked a little bit about watersheds. We know what those are. Above an aquifer is a recharge zone. So that's the area of land above an aquifer that serves to filter the water as it seeps into the ground and sinks down until it hits that impermeable rock or bedrock. And based on its porosity and permeability, it's going to be able to filter those a little bit differently. So some of those pollutants are going to be able to be removed from the water and stored or fixed in the earth itself. So porosity is a measurement of the amount of water a certain amount of land can hold. And that's just based on the size of the holes or pores that dirt or rock has between it. So if you think about a cup of sand versus a cup of gravel is going to have more empty space between all the individual little rocks versus the air that's in between the individual grains of sand, right? And similarly, if we were to pour water through both of those, the water itself would have different speeds at which it can move through that gravel or the sand. And that's permeability, all right? The image below me shows the Edwards Aquifer recharge zone, and it shows what it labels a drainage area, a recharge zone, and an artesian zone, or an artesian zone. So the drainage area is where water mainly seeps into this underground water table, and as we see it move across the image, that water table actually changes elevation. And when that happens, we have things like springs, and the recharge zone itself is downstream. And we're talking pseudo downstream here because the aquifer itself is mainly on the right portion of this screen. Well, that side for you guys, my right when I'm looking at it. And we can see that the water does seep down into the earth and it moves through a few different layers of soil and rock on its way there. We can also see springs and wells in the image as well that show humankind able to use the water from the aquifer. And different layers of a recharge zone can filter different things. So we've got vegetation and topsoil that can filter larger particulates. It may also hold bacteria that can eat or digest or break down. All those three words mean the same thing here. Pollutants into non-harmful material. And then below that is a finer particulate. So in this case, it's sand and some kind of carbon source, so probably some sort of charcoal. And those things can work to filter the smaller particles. Charcoal and activated charcoal can even filter out dyes from water, which is something that's particularly hard to do. And then they have what's called a transition layer and a drainage layer in this image, and those are mainly to actually, sorry about that, my nose itched really bad. Mainly to stop the stuff above it, all those layers above it, from entering this collection pipe. Right? And the collection pipe can be thought of as a mirror to the impermeable rock layer below everything that would serve as the bottom of an aquifer. In this case, it's moving the water off-site as treated stormwater, and people can use that for multiple different things. It's still not quite potable, right, drinkable. It would still have to go through a treatment plant, but it has been partially treated in a very low cost, natural, low energy cost environment, right? So when we're talking about the pores, those are the holes inside of dirt, sand, rocks, gravel, any kind of particulate media. The larger the hole, the less stuff it can filter out, but the faster water can go through it. The smaller the hole, the more contaminants it can filter out, but the slower the water moves through it. So you're going to want different layers and a mix of different porosities to filter out a larger amount of contaminants. Right. The lithosphere, remember if you don't, that lithosphere talks about the rocks and dirt and crystal structures, and so those are minerals, and sand and all the earthy parts of the ground. And so it works as a natural storage place for some of the water in the hydrosphere, as well as a dampener for some of the kinetic energy in the hydrosphere. So it works to slow down things like tides and streams, anything with a large amount of kinetic energy. That kinetic energy has to go somewhere, so parts of the lithosphere can act as buffers against that. From sandbars on the sides of bays that slow down tides entering to provide a natural habitat or a lagoon, to something like this, where there's a bunch of peat, which is just a special type of a certain type of soil that holds a lot of water, and it's characteristic of swamps and bogs, as well as wetlands like the one pictured here. So it absorbs all the kinetic energy, that energy of movement of water entering this area, and dissipates it over a larger surface and slows down the area, that stream, before it moves out into a larger stream or a river, which prevents erosion on the banks of that other stream. And it also provides a area for contaminants and sediment to be filtered out as it slows down and it can sink to the bottom. Bacteria can live in the soil here and break down some of those contaminants, and groundwater can actually seep into the waterway and move out of stored ground slower, so it's more stable over a longer period of time, whether that be days or months. It's going to depend on the environment itself. No two are exactly alike, and the science behind them is fascinating. Scientists are taking multiple different routes to treating water pollution, but the main goal is always to prevent water pollution. If we can stop pollution before it enters our waterways, it means we don't have to treat it. And it's much easier to prevent it than it is to treat it. Right? So we've already talked about sources of water pollution already. Now we're talking about fixing those water pollution pollutants. So there are two main ones I want to talk about. One is the pump and treat method. One is bacterial remediation. So pump and treat is what it says on the tin, right? We've got pumping and we've got treating. So pumping means you have to move the water. So you're removing the water from wherever it was, be that a creek, a stream, a pond, or an aquifer. You're pulling it out of that area, putting it into storage tanks and pipes and treating it. So that's done through filtration, it's done through chlorine treatments, and then you take that water and you put it back where it was so that the overall water level doesn't go down or decrease. You don't want to remove water from this place. You don't want to lose the water to evaporation or that kind of thing. So it has to be very efficient, and it's very labor intensive because it takes a lot of man hours to do all that stuff. Bacterial remediation is something we've already touched on. We talked about how bacterial in soils can break down pollutants into non-harmful molecules. Bacterial remediation is purposefully injecting bacteria into soil, into water sources that isn't going to contaminate the water further, but rather break down those contaminants themselves, usually into nitrogen gas and water. Right? It does depend on what the actual pollutant is, though. We are also working on, when I say we, I mean scientists as a whole. There are scientists working on bacteria that can handle radiation exposure as well. which can absorb the radiation and break those energies down rather than breaking down molecules. And that can help in places that used to be involved in depleting uranium to the water used in cooling of nuclear power stations. Right, so we talked about how Earth naturally filters the pollutants in a water system through the lithosphere. And we talked about a couple of the different ways that scientists are removing pollutants from Earth's waterways. But remember, scientists are mainly focusing on prevention because prevention is a better route than treatment. Right? As always, keep learning and keep asking questions. Have a good one.